can start. Sure.
Go.
Okay, so what we've designed is an acoustic impulse marker, also known as an aiming system.
Nice.
So
Okay.
it actually takes a sound signal and actually points using a servo motor to the location at which the sound actually came from.
And you're using a pencil as a pointer, which I like.
We're using a pencil to point right now. Yes, you kind of put anything on there, but it was just it's arbitrary. So.
And as we're talking, it's actually turning to approximately where you're talking from.
It is. Yeah, we found that it's far better at sharp noises like a snap or a clap.
Okay.
It's not as good as getting smoother sounds like speech or conversations.
Because you're doing rising edge detection.
Right. It's looking for a sharp edge.
Now, on the top are 3 microphones which allow you to get time of arrival from any direction, right?
Right. So the 3 microphones take the time that the sounds have been taken and find the 2 times that are closest together. This gives us an angle closest to 90 degrees. And the closer to 90 degrees, the better the angle approximation is, because we're close to the microphones, and the microphone system assumes that we're infinitely far away.
Oh.
After we find which is 90 degrees, we use the 3rd microphone to determine which side the sound came from. Mm-hmm. And using this, every calculation is within 30 degrees of 90, which gives us very accurate calculations when we reach it.
Okay, so snap your finger a few times. Let's see this thing go. Wait a minute, let me get back far enough I can see where you're snapping. Okay, so if my fingers are not doing the job here. Okay, got me on that one. All right, now snap over towards my left, and it goes left. Now snap to the right. Very good. Okay, so it is certainly responding to voice at times. But it does do impulses much better.
Right. So when you're speaking, the waveform of your voice is a lot smoother, and also might have a lower peak before you hit a sharp peak where it can actually detect your voice.
Mm-hmm.
So when you snap, it's just one simple peak.
Right.
Whereas a voice gets ignored a lot.
And you geared the servo 2 to 1 so that you could take a 180 servo and make it into a 360 servo.
Right. Exactly. Yeah,
That's,
so we have
it's a nice rigid looking system there.
Yeah, it just uses 2 gears, and like you said, the 180 degrees of the servo basically converts it to a full 360, so it'll actually pick up anywhere around it. It'll pick up sounds.
Okay, very good. Now let's point to the circuit board down here and tell me what's on the circuit board.
Sure. So this is actually an 8-stage circuit. We have 3 identical circuits for each microphone. First, the microphone gets biased and goes through a passive high-pass and low-pass filter. Then we've got a first gain stage with a gain of 100, and then a second gain stage with a gain between 2.5 and 5. And what this allows us to do is to tune the amplification to be the same on each component, since none of these components are perfect. After that, we go through a high-pass filter to get rid of the DC offset, and then we go through a peak detect circuit and a Schmitt trigger in order to find the rising edges and then trigger them so that the microcontroller can use them.
And you have to do the Schmitt triggering off of the microcontroller because the A to D converter is not fast enough to get speed to sound.
Right.
It can get digital edges, but it can't get the analog edges directly.
Right.
Yeah, it's all done in analog circuitry.
Okay.
So the microcontroller is actually doing all the data acquisition of the timing
of the edges.
It's doing that all in interrupts, so it's as fast as possible.
Mm-hmm.
And then once it gets that, when it has free time between noises, it does all the math to calculate which angle it came from, because that's much more lengthy computation.
Right. Okay. All right. Thanks.